Welcome sa ating next course, Discrete 1. Ito yung ating lesson 1 sa finals at ito na rin yung last topic natin, last lesson. If you notice dito sa buksan natin itong ating module. If you notice ay ito na lang yung lesson na natitira, no? Ayan. Lesson 9, trees, and then after that you can take the quiz and the final exam, but we will have to wait for the final exam date, no? But the quiz, okay, I will open now the quiz so that after this lesson anyone who is ready can take the quiz, no? So yan, naka-open na siya. So we go now and discuss trees, no? So this is the outline, no? We will talk about the definition ng trees, no? Introduction, tree, what are spanning trees, rooted trees, m-ary trees, ordered rooted tree, binary tree, and binary tree traversal. Now, if you'll notice, 51 pages to, or 51 slides. But don't worry, marami sa kanila ay exercises. So, I will be just discussing one exercise per topic, no? Para hindi tayo matagalan kasi kung isa-isay natin yan, hindi kakayanin ng oras sa video, no? Okay, let's start. So, the concept of trees are used in everyday life. Some common applications of it are tournament tree, no, used to describe the outcome of a series of games, no. Yan, makita nyo itong example dito. Okay, so that is an example of tree. Much of tree terminology derives from family trees, no. So ito, merong yun, kung ito yung nasa taas, probably ito yung lolo, ito yung tatay or nanay mo. Okay, Chaos, Cronus, Rhea, yan, Hestia yung mga anak, Hades, mga children, no? Poseidon, Zeus, Demeter, Hera, yan. This is an example of a family tree. Okay, a tree is also a graph. Makita nyo dito. Okay? So, the same composition with graph as we've discussed in modern mathematics, no? So let G equals VE. G stands for graphs or graph, and the V, you will notice that this is a set, no? And the set is composed of B, which represents the vertex, and E represents the edge. Okay? So a graph consists of a vertex and an edge. Be a loop-free, undirected graph. But a tree is a graph which is a loop-free and undirected. Ibig sabihin, wala itong circuit, yung tinatawag nating close, no? Hindi siya close, no? And also, walang direction ng kanyang edge, no? Okay? Kaya ang tawag sa kanya ay undirected. The graph G is called a tree if G is connected and contains no cycles. Okay? So may mga example tayo dito. So example, the graph is an undirected graph and contains no cycles, thus it is a tree. Okay? So this one is a tree. Okay? Undirected, no cycle. Okay? So this one is a tree, this one is a tree. Example, the graph is not a tree because it contains the cycle AB. Ito yon, AB. So, it goes round and round, no? Yung path na to ay circuit dahil siya ay close. But this one you can consider if you break this one loose, if you separate it from the top graph, then we can consider this as a tree. But as long as it connects with this graph, then we cannot consider them, or we cannot consider it as a tree. This is also not a tree, no, because it is not connected, no. There is a separate graph, no. When graph is a tree, we write T instead of a G to emphasize tree structure. If A, B are distinct vertices in a tree, T which is equal to VE, then there is a unique path that connects these vertices. Since T is connected, there is at least one path in T that connects A and B. If there were more, then from two such paths, some of the edges would form a cycle, but T has no cycle. So which of these graphs are trees? Okay? So exercises na to. So I will give you the time to answer this on your own. Okay? And you can also check the solution after each exercises. So what are spanning tree? If G equals V is an undirected graph, then G is connected if and only if G has a spanning tree. The spanning tree of a graph G is a subgraph of G that contains every vertex of G and is a tree. So every connected graph has a spanning tree. A graph may have more than one spanning trees, and only two spanning trees for a graph have the same number of edges. If a graph is a tree, then its only spanning tree is itself. Katulad nung example ko kanina na pag break natin o separate natin, then it will become a tree. That is an example of spanning tree. Okay? So find the spanning tree of the graph. So breaking up this graph, we can find a spanning tree. Okay? For example, the graph has 6 vertices A, B, C, D, E, F and 9 edges. Following the formula that the tree of vertices n has n minus 1 edges, 6, 1, 5. Therefore, the tree should have 5 edges. Okay? So kailangan kasi sa tree ay yung n minus 1 that would give us the number of edges, Yung n kasi is the number of vertices. So yung vertices is always 1 greater than the number of edges. So if we minus 1, then it will give us the number of edges. For example, this one has 6 vertices, A, B, C, D, E, F. So 6 vertices minus 1 will give us 5. So if you count, there is 5 edges for this graph. Okay? So this is the spanning tree coming from this graph. Okay? This is not a tree, but if we cut loose some of the edges, then we will get the spanning tree of this graph. Okay, this is also a spanning tree, but when we delete an edge in this cycle, the number of edges to be deleted is equal to E minus B plus 1. So yung edges minus vertices plus 1 daw, then it will give us the number of edges that should be deleted, So since E minus V plus 1, then in every tree, BE, V equals E plus 1, a tree is not a tree if it has edges is greater than or equal to the vertices. So lahat ng spanning tree or tree, dapat yung number of edges, yung nakita nyo, if you remember from discrete 1, yung symbol na double bar is symbol for its cardinality. So cardinality of E should not be greater than or equal to the cardinality of the vertices or V. Okay? If we want to call the graph as a tree. Okay? So dapat wala yung number ng edges hindi mas malaki or equal sa number of vertices. So these are exercises, so you can solve it for yourself. We go now with the following statements are equivalent for a loop-free undirected graph GBE. G is a tree, G is connected, but the removal of an edge from G disconnects G into two subgraphs that are trees. G contains no cycles, and V is equal to E plus cardinality of V equals cardinality of E plus 1. So G is connected, and V, or the cardinality of V is equal to cardinality of E plus 1. Rooted trees, if G is a directed graph, then G is called a directed graph if the undirected graph associated with G is a tree. When G is a directed tree, So G is called a rooted tree if there is a unique vertex R called the root in G with the in degree of R is equal to IDR equals 0, and for all other vertices V, the in degree of V is equal to ID times V is equal to 1. Okay, so ibig sabihin nun, a rooted tree should only have one vertex at the top. Okay, so the tree is rooted but not, okay, this is not rooted because there are so many connected vertices, no, with so many edges. Okay, so a rooted tree should have one vertex that has only one edge from it, no, coming from it. So rooted tree with, this is an example of rooted tree with the rooted R. Okay, so I mean yung 1 is not 1 but 2. Okay, at least two uh, two edges coming from the vertex. Okay, suppose that T is a rooted tree if V is a vertex T other than the root. The parent of V is the unique vertex U such that there is a directed edge from U to B. So, if U is the parent of V, V is called the child of U. So, para maano nyo, naintindihan nyo yung explanation, ay kunin natin to. Okay? And then, kunin din natin to. Lagay natin sa tabi. Okay? Pagtabihin natin. Yan. And then, ito tayo dito. So, if V daw is a vertex in T, okay, other than the root, the vertex of V is the unique vertex U such that there is an directed edge from U to B. Okay? If U is the parent of V, then V is called the child of U. Okay? So kung ito daw si V ay nasa ilalim ni U, okay? Yan. Then ito yung parent. Okay? And then ito yung child. Okay? Si V yung child ang tawag sa kanya. Okay? Vertices with the same parent are called siblings. For example, the same parent yan. Ito, parent niya is si N. So, itong dalawa si Q and S ay siblings. Okay? The ancestors of a vertex other than the root are the vertices in the path from the root to this vertex, excluding the vertex itself and including the root that descends. Okay? Including the root. Okay? So, pag sinabing ancestors, for example, ito yan. Ancestors to nitong tatlo. Okay? Ito. At ito naman yung kanilang parent. The descendants of vertex V are those vertices that have V as an ancestor. So, kung ito yung ancestor, so ito yung descendants niya, no? Ito yung mga to. Yan. Descendants niya. Lahat ng nasa ilalim niya. Or, linisin muna natin. Kung ito yung ancestor, yung nasa ilalim niya mga descendants, no? So, ito rin naman, pwede nating sabihin descendants niya tong mga to. Kasi nasa ilalim niya eh. Descendants ni N. Okay? Ano pa? If a vertex of rooted tree is called a leaf, it has no children. Yan. Okay? So, kapag daw sinabing leaf, walang children. So, ito leaf, 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 leaf. Okay? Walang mga anak. Okay? Vertices that have children are called internal vertices. So, ano yung internal vertices? Ito, mga internal vertices. Dahil meron silang anak. The root is an internal vertex unless it is the only vertex in the graph, in which case it is a leaf. If A is a vertex in a tree, the subtree which A has its roots is the subgraph of the tree consisting of A and its descendants and all edges incident to these descendants. Okay, malito ron. Ibig sabihin lang nun is, ito daw mga to, kung may makakakuha ka ng kaparehong structure, no? Ito ay subgraph. Yan, subgraph yan itong malaking graph. So, pag tinanggal mo siya, graph din siya, siya ay tree din, no? Pero galing siya dito, so siya ay subgraph. Okay? O kaya ay subtree. Okay? So, yun lang ibig sabihin nun. And this can also be a subgraph or subtree. But this one, yan, ito, kahit ito, no? Yan. You can also call this a graph, no? But, subgraph, but not necessarily a tree. Ito, sub-tree. Ito, sub-tree. Yan. Okay? What is m-ary rooted trees? A rooted tree is called an m-ary tree if every internal vertex has no more than m children. Okay? So, ibig sabihin ng m children is yung mas marami pa sa dalawa. Okay? A tree is called a full m-ary tree if every internal has exactly m children. Okay? So, katulad nito, yan, exactly, it is an m-ary tree. Okay? If more than, no? Ito m-ary tree. M-ary. If has no more than m children. So, ito yan. M-ary. Kasi isa lang yung anak niya. Ito, full m-ary. Okay? Full m-ary. And can also be called a binary tree. Ayan, binary tree. Okay? So, ang tanong is this a full m-ary tree? This is not a full, ito, ibig sabihin ito, itong buong tree na to. Is this a full m-ary tree? The answer is no. Since yung kanyang isang internal vertex, yan nakalagay dito, internal vertex has no, not exactly m children. Ay, isa lang yung anak niya. Okay? So, this is not a full m-ary tree but can be called only a binary tree. Yan, full binary tree because each of its internals has two children. Okay? Full binary tree. Full trinary tree because each of its internal vertices has three children. Kung tatlo na, then hindi na binary yun, no? Trinary na. This is not a full tree because some of its internal vertices have two children and others have three. So ito hindi siya magkakapareho, no? So may kulang pa, so this is not a full m-ary tree. Ordered rooted tree. An ordered rooted tree is a rooted tree where the children of each internal vertex are ordered. Ordered rooted trees are drawn so that the children of each internal vertex are shown in order from left to right. Yan. Determine whether the following trees are rooted or not rooted. So this is rooted, this is not rooted, this is rooted. Okay? These following exercises you have to solve by yourself. Okay? Binary tree. An ordered binary tree usually called just a binary tree. If an internal vertex has two children, the first child is called the left child and the second child is called the right child. So, katulad nito, binary tree to, no? So, na tayong left child, Meron tayong right child. And the tree rooted at the left child of vertex is called the left subtree of this vertex, and the tree rooted at the right child of vertex is called the right subtree of the vertex. Okay, this is an example, not a binary tree. Not a binary tree kasi merong magka-share ng edges doon, no, sa baba. What are the left and right children of D in this binary tree? Okay? So, ito yung left, ito yung right. Okay? The root of the tree is A, B, C are the left child and the right child, respectively, of the parent A. So, B and C are the siblings. The left child and the right child of A. The nodes are siblings if they are left child and the right child of the same parent. The root of the binary tree has level 0. So, yung sinasabing level is ito. Okay? Yan, level 0. Yan. Ito naman, level 1. Yan. Pagdating dito, level 2. Nakapansin nyo, ito yung ginamit ng networking, no? Yan, level 3. Okay? So, yung level yung sinasabing pag mga bagong saling lahi, kumbaga, kung ito ay family tree, no? Next, the tree traversal is specific order in which to visit the nodes of a tree. Pag sinabing traversal, that is a meaning nun is to visit, no, or pumunta, no. For example, traverse from R to N to Q and to U. Ibig sabihin, pumunta ka galing kay R, puntahan mo si N, si Q, at si U. There are three common tree traversals. In order, unang type is in order, which is left, root, right. Okay? So, yun. So, ibig sabihin nun, ganito. Kung magbibisit ka raw, magta-traverse ka sa isang tree, we have three types: in order, pre-order, and post-order. So, in order, ang direction natin is from left, here, okay, going to the root, and then going to the right. Yan. Okay? Sa pre-order naman, we go to the root, we go from the root to the left, and then to the right. Okay? Sa post-order, we go from the left, right, and then root. Okay? The order is applied recursively. Ibig sabihin, recursively is repeatedly or paulit-ulit. Yan, ganoon. Hanggat hindi niya nabibisit lahat ng nodes. Okay? Lahat ng vertex. Okay, in order, traversal. To visit the tree, first visit is left subtree, then visit the root, then visit the right. Kasi yun yung ating order, yung ating direction ng in order, no? So, from the left, we visit the root, and then we visit the right. So, ang ating direction, gagawin kong red, yung ating, para mas maganda. So, from F, ito pa, teka, iba na pala yung example natin. So, gamitin natin to. Example. Yan. So, from F, we go to D, we go to G, we go to V, we go to B, to E, and then root, A, then we go to J, we go to H, then Z, then K, then I, then M, then L. Okay? So, yun yung ating in order, no? So, from left, then root, then the right nodes. Okay? Next, pre-order. So, sa pre-order, kunin uli natin to. Sa pre-order is we start from the root, then sa left, then D, then F, then G, then E. Then we go to the right. Excuse me. C, H, J, I, K, L, M. Okay? So root, left, then right, 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 until sa end ng right nodes. Okay? Sa post order naman is, again, we will take this. We have to visit from the left, then the right, then the root, no? So F, sorry. So F, G, D, E, B. Then, hindi tayo punta sa root, punta tayo sa right. J, H, K, M, L, I, C, then the root A. Okay? So, if our machine, if you will going to program a machine, no, that would read a binary tree data, okay, we can use these three types of traversal. Okay, in order, post order, and the pre-order, no? So in order, pre-order, post order. Next, these are our exercises. So this is the end of our lesson for discrete, discrete 2, discrete 1, sorry. Okay.